So, could you tell me what you have here? You have cameras of various sorts. You actually manufacture these modules, right?
They are manufactured in Korea by a company called Scoopy. What we have, you can distinguish in between. This is what we call the board camera.
Uh-huh.
You get them in various sensor levels, you can say, from VGA up. Normally they have HD SDI as an interface in between. And you can have them in houses or that for your own building. This guy here is what we call the block camera.
Yeah.
It includes a lens, a zoom lens, autofocus. You can reset focus, whatever. You have this on this one here. You have HD SDI or LDVS out. You can run it by RS232 or Visca. Same protocol. So it's also, as you can see.
So the SDI interface, when I interface that to an embedded board, what would I usually use?
So to get it, you need the interface in between. But or if your embedded system has the interface for HDSI. If it doesn't have...
Do you have interfaces, for example, to make this one a network camera?
Yeah, that's another story.
An Ethernet camera?
You need, those are IP cameras you can see here. But there is additional boards for those. That converts this signal to IP.
Okay, so this is more like the camera module itself that actually has the zoom and the lens.
That's the way you should see it. Then it's up to you to do the rest. So
Okay, all right.
But it's a complete module up to the end, so you get electrical signal out from it. So.
What is the radio antenna output here for?
No,
what's that? Is that
no.
What is that? That looks like a...
That's a screw for some reason, or a cooler, or it might be a coax connection.
That looks like a coax connection, yes.
Then you have the micro-coax connection.
But that's also video signal.
Yeah.
Okay.
Yes. Then if you want a more, upgraded, this for instance here, then you have USB 3.
Yeah.
Which is common one. You have the picture here. Let's see if it's up and running. No, it's frozen again. The computer is a bit weak. But anyway,
that's pretty long latency.
Really? Yeah. No, I need to restart it. So I've been overloading it. I have two cameras in this model. There's an M processor inside, so you can hardly get it. But anyway, what I'd like to show here is on the lens side here, you can actually move the focus. Now we have frozen image, we can't do it by what is called a liquid lens.
Right.
Meaning no moving things inside. You do it by liquids and inserting a tension up to 70 volt on the lens itself. The lens inside looks like that.
Oh, that's very nice.
Yeah, and you combine it with other lens element as is done here, and then you apply.
And this is the actual electrical connection for making the lens contract and expand.
Exactly. Yeah.
Really nice. So do you manufacture these lenses, or is that
no? They are produced by Corning. Company Corning. And a part of them called Varioptic is in Lyon, France.
Okay.
So I bring them up to Nordic.
Varioptics.
Yeah.
Nice.
So I bring them up as a rep then to Nordic countries. There's other versions of it only, but it's the same.
So you can, in theory, use one of these for a laser, for example.
Yeah. Then, because you see, this is a kind of you can see it as a single element lens. If you like to do a picture of it, meaning in a camera, you need a better field. And of course you need additional lenses around it. Yeah. And we have those kind also. I have one installed there.
Yeah. I would very much be interested to see the output of this middle class camera. I suppose this one is the high end.
Yeah. So what is the difference in between those is actually the sensor, of course, but also the zoom factor. This one is 30 times, the smaller one is 10 times zoom.
Right. In terms of quality, though, are they roughly the same?
Roughly the same,
okay. So even the light sensitivity is pretty much the same. It's just the zoom factor that's bigger here.
Yeah. The lower the zoom, the bigger the lens.
Yeah.
And quite frequently you need small stuff, meaning. Small cameras, you're going to shoot it in a small housing or behind the rear wheel mirror in something in a police car or whatever they are.
Yeah.
They use mainly for surveillance or observations, you can say.
Can you show me what the image looks like?
No, we have none of those connected.
Okay.
Just now.
And this is some...
This one connected here.
Can you connect it?
This one, okay.
Oh, so this is that one, and it's the same one as this one, right?
Exactly.
No, it's not the same one.
It's not the same.
That one has a slightly lower image, but what we've done is this one has, at the moment, you're looking at the AHD output of this camera.
Okay.
This is the AHD output via the DVR.
So this one is connected. The camera is connected to.
No, that's
A little- this is just an adapter.
A help board. It's connected AHD to the DVR, and then the DVR gives the HDMI out here. That's
Okay.
what you see. That's why in this image you see the different overlays. And for
Right.
example, a meter read, if you see there, if I turn, I can get to a different meter perspective. So I can also measure how far a robot, for example, is inside a cabbage or something like that.
Yeah.
Yeah.
Do you have encoder boards that? Is it possible to modify this overlay that you get over the image in real time, as you encode the image and send it perhaps over network?
Yes. So this is the real image without the overlay.
Yeah. Let's say I want to render directly to the overlay, because it's very important that the image is very low latency. So even a fraction of a second is too much, because if you're controlling a robot, for example, and you want to have the video feedback, you really have to have as low latency as possible.
I understand.
And
But now you're asking a few things. What do you want? Do you want, because if you want the overlay,
I want both the camera overlay and an encoder board that can send the signal over network.
yes. But there are certain things that you have to understand.
And a small form factor too, because this one is like this one is gigantic.
Let's start with what is your application?
I'm thinking robotic application, because I've had a customer recently who had a small robot, and he had a really bad camera on it. But I'm thinking that in general, I'm very interested in this. It got me thinking, like, can I find a camera that is very low latency, high resolution, that fits into a small area, maybe this big, and where I can render different parameters or different sensor values directly on the overlay without too much effort. And the low latency part is obviously major.
Okay.
So I can't.
So let's go back. First of all.
Okay, I have to stop this video now, but I might start another one because I have no more memory left.